Hi there. My name is Jonathan Lee. I'm a machine learning engineer at Samanova Systems. And in this video, I'll be talking about our paper SnapStream, which we'll be presenting at ISE High Performance 2026 in Hamburg, Germany. In this slide, you'll see the full title of our paper, Efficient Long Sequence Decoding on Dataflow Accelerators, as well as my contact details. So the application or domain that's impacted the most by our work is large language model inference, and in particular, the memory requirements of LLM inference on hardware accelerators. So at a high level, SnapStream is a KV cache compression method targeting disaggregated prefill decode inference deployments of large language models. So the background being that large language models reaching 100 billion plus parameters and consuming and producing 100K plus sequence length have severely increased the memory requirements of inference, and in particular KV caches. And so SnapStream is basically a work that attempts to bridge the gap between KV cache compression methods that are studying in academia and sort of the prefill decode inference modes that we see in LLM inference in production. So the most important innovation in our work is the compression methodology, what we can separate into the algorithm and our implementation. So the algorithm takes into account the fact that prefill and decode, the two stages of LLM inference, are usually allocated to different hardware resources, whether that's a single socket or a single node or a cluster of nodes or a different number of nodes for each. So you can see the diagram, which is figure 3 in our paper, that the KV cache structure looks a little bit different in the SnapStream version of both prefill and decode. And that's to account for the sync, top K, and recent windows that are a big part of the compression methodology that we apply to the second part of our contribution, which is the implementation in fused kernels. So we demonstrate how we integrate the different operations that we introduce in SnapStream into the existing optimized fused kernels for both prefill and decode. In our case, we use the example of Samanova's accelerator, the reconfigurable data flow unit, or the RDU. And you can see in figure 7 how compressed KV cache and valid top K metadata from SnapStream operators are used in existing fused kernels for decode. So an important performance results from our work can be summarized briefly in table 5, which shows and compares the different deployment configurations of a large model like DeepSeek R1 on 16 sockets of our accelerator SN40L. You can see that SnapStream allows us to achieve a much higher batch size for various compressed sequence sizes and up to 4x higher throughput. Thanks for listening. Please check out the full paper in the conference proceedings and an archive.